Hi, everyone. Welcome to the lecture video for Chapter 6. You can find the associated notes in the Week 5 module. Chapter 6 is all about confidence intervals, which is all about making estimations of population parameters using sample data. So I want to remind you population or numerical data when representing a population has often has two important parameters, the mean and the standard deviation. And binomial data, proportions, has two important parameters, the population proportion and the population standard deviation. The standard deviation of the population proportion. You can build a confidence interval around any population parameter. We are going to focus on the on confidence intervals for population means and population proportions. All right, let me add population here. Okay. All right. So at its core, a confidence interval is a best guess and a reasonable range. So for example, I know that, in general, the height of a population of people will have an average height of about 68 inches. And that's 5 feet 8 inches. And so that's my best guess. If you ask me, what do you think the average height of that population of people is going to be? I'll tell you, well, I think it's going to be 68 inches. However, I don't think my guess is going to be exactly correct. So I want exactly correct. So I want a reasonable range for what I think the population mean will be. For example, I am quite confident that in any given human population, the average height will be between 5 feet 4 inches and 6 feet 6 feet flat. And that's my reasonable range. And we call this the confidence interval. So that's what a confidence interval is at its core. To determine a confidence interval mathematically, let's say for a mean, we need, based on a sample, we need the following information. First, we need what is called the confidence level. And this is a choice of the person creating the confidence interval. It is how confident the person wants to be. The most common choice for the confidence level is 95%. so that the person can say, I am 95% confident that the population mean is in this interval. Other typical confidence levels include 90%. I am 90% confident that the population mean is in this interval, and 99%, which has a corresponding statement. So that's the first thing. You pick your confidence level. You need to know your sample mean. This will always be your best guess. You need to know your sample standard deviation. We call this S. You use this to create your reasonable range, i.e. the confidence interval. And with those three pieces of information, I guess there's one more. You need a z-score based off of the confidence interval. Remember, the z-score is a number of standard deviations, and it works like this. 2 standard deviations above and below or below the mean includes about 95% of data. So a z-score equal to 2 is chosen when you use a 95% confidence interval. 1.65 standard deviations above or below the mean includes about 90% of the data. So your z-score equals 1.65 is chosen when you use a 90% confidence. And different confidence intervals give you different z-scores, and it's pretty easy to figure out the z-score. How do you pick the z-score based on the confidence interval? You can use R. So let's hop over here to R. I'll clear this out. Start a new script. Picking a z-score for based on confidence level. Okay. So let's take a 95% confidence level. It means 95% of the data is between the z-score above and below the mean, which means that 5% of the data is outside the z-score, which means that 2.5% of the data is larger than the z-score. So we'll use p-norm, q-norm, to find the z-score associated with 2.5% right tail. Q-norm, our p-value, oh, one more step, which means 97.5% of the data is smaller than the z-score. There we go. So Q-norm usually use left tail. So we're going to use a Q-norm to find the z-score associated with 97.5% lower tail or left tail. So we take a Q-norm, we take 0.975. We're going to use our standard normal distribution, 0 and 1, run it, and we get 1.96. 1.96, which is very close to 2, which is why we use 2 for a 95% confidence interval. If I want a confidence interval for CI, confidence interval, and let's do an 80% confidence interval, so pretty low confidence. 80% confidence interval means 80% is between z-scores, which means 20% is outside z-scores, the positive and negative, which means 10% is greater than the z-score, which means 90% is less than the z-score. So we're going to use Q-norm to find the z-score associated with a 90% lower tail. Q-norm 0.9, 0, and 1 to use our standard normal. We run it, and we get 1.28. Okay, that's how we get these various pieces of data. Once we have these 4 pieces of data, the confidence levels we pick 95%, the sample mean, which you compute from the data, the sample standard deviation, which you compute from the data, and a z-score, which you can get mathematically based on the confidence interval you choose. And with these 4 pieces of information, you can create your confidence level, or sorry, your confidence interval. Let me copy this in to the lecture notes. Okay, so the confidence interval for a mean is defined to be the it equals the sample mean plus or minus the z-score. Let me write this all in words. Plus or minus the z-score times the margin. So it would be CI equals X bar plus or minus z-score times margin of error. And the margin of error is I'm sorry, I misspoke. Let me restart. The confidence interval for mean is the sample plus or minus the margin of error, just the plain old margin of error. So confidence interval is the sample mean, X bar, plus or minus the margin of error. And the margin of error is the z-score times the standard deviation of the sample mean. Recall that from chapter 5, that a sample mean has a distribution. So there is also a standard deviation of the sample mean. So margin of error is z-score times the standard deviation of the sample mean. I'm going to give you an example now. Suppose you collect a sample of 20 people and measure their height. The mean height in your sample is 67 inches, and the standard deviation of the sample is 3 inches. Let's use this data to construct a 95% confidence interval for the mean height of any population. How about the population that the sample comes from? So the confidence interval is your best guess and a reasonable range. Your best guess is the sample mean, which is 67 inches. The reasonable range is the z-score times the standard deviation of the sample mean. So your z-score comes from the 95% confidence level. And in this case, it's going to be 1.96 or 2. Let's use 2. And the standard deviation of the sample mean is going to be the standard deviation of the sample divided by the square root of the sample size. Think back to chapter 5. A sample mean has a distribution. Its central value is the same as the central value of the population. The standard deviation of the sample mean is smaller than the standard deviation of the sample, so you divide it by the square root of the sample size. Standard deviation of the sample mean is 3 divided by the square root of 20, which is 0.6708. So the reasonable range, which is the z-score times the standard deviation of the sample mean, equals 2 times 0.0671. Probably 0.067 is good enough. Sorry, 0.67, which equals 1.34. So your confidence interval can be reported as 67 plus or minus 1.34. It could also be reported as figuring out what those numbers actually are. So 67 minus 1.34 up to 67 plus 1.34. Which is 65.66 up to 68.34. This is your 95% confidence interval. And that's how you construct a confidence interval. Let's go through the steps again. First thing you should do is choose your confidence level before you actually calculate the confidence interval. Then you develop your best guess and your reasonable range. Your best guess just comes from the sample mean, sample of 20. Your reasonable range comes from the z-score that you find using your confidence level and the standard deviation of the sample mean, which is the standard deviation of the sample divided by the square root of the sample size. And then you build your confidence interval as the mean plus or minus the standard error, or you go as an interval from the lower bound to the upper bound. Let me do another example. And this time I'm actually going to use that data from way back in chapter 2 when we were doing our descriptive statistics. So let me grab that and be right back. Oh, I thought I paused it. I didn't pause it. Sorry. You saw me jumping around. I'm not going to edit that in post. It's too much work. So there's our data. Let's construct a 90% confidence interval for the mean of the population represented by this sample. So step 1, choose our confidence level. We did, that's 90%. Step 2, let's find a z-score for the 90% confidence level. I told you earlier it's 1.65, but let's just confirm. So we're going to do Q norm, and our probability is going to be halfway between a confidence level and 1, so it's going to be 0.95 with a mean of 0, standard deviation of 1, and there it is, the 1.64 or 1.65 that I mentioned earlier. I'll change that so it's the same. Okay. All right, step 3, find the mean and standard deviation of the sample. So here's our data over in R. We're going to find the mean of that data and the standard deviation of that data. The mean is 101.78 and the standard deviation is 9.42. 9.42. Okay. Step 4 is find the standard deviation of the sample mean. Remember that there were n equals 50 observations. So that's going to be 9.42 divided by the square root of 50. Which is 1.33. I'll abbreviate this so it's all on one line. Standard deviation of the sample mean. Step 5, construct the confidence interval using the best guess and reasonable range. So it's my 90% confidence interval is going to equal 101.78 minus 1.65 times 1.33, sorry, plus or minus 1.65 times 1.33. So that's 101.78 plus or minus 2.1945, which equals, if I write it as a confidence interval, goes from 99.59 to 103.97. So that was 99.59 to 103.97. And there's my 90% confidence interval. Interpretation based on my sample, I am 90% confident that the true mean of the population is between 99.59 and 103.97. And my best guess is that the true mean is 101.78. All right, those are the mechanics of the confidence interval. The actual construction's fairly straightforward. So let's talk about a couple of things that confidence intervals are and a couple of things that confidence intervals aren't. Confidence intervals are educated guesses based on data and some mathematical theory about how sample means work, in particular the central limit theorem. Confidence intervals are not are never 100% accurate. In any confidence interval, there is still a chance that the true mean is outside the interval you report. For example, in my 90% confidence interval, I think that there's a 10% chance that the mean is actually outside of this interval because there's a 90% chance that it's inside this interval. To increase your confidence level, you need to increase the size of the interval. If I want to be more confident that I'm not missing the true mean, I need to make this interval wider. To increase your confidence level without increasing the size of the interval, you can always collect more data because a larger sample size improves the accuracy of statistics. Confidence intervals do not tell you the maximum or minimum for sample data. They only give you an estimate of the parameter, in this case, the mean, that you are estimating. All right, I want to show you how to do a confidence interval for a proportion. We need similar data. So to construct a confidence interval for a population proportion, you need the confidence level, which you pick, the z-score, which comes from the confidence level, right, just the way it was before. You need the sample proportion, is like the sample mean, and you need the standard deviation of the sample proportion, which is similar to the standard deviation of the sample mean. So let's look at an example. You ask 24 people if they like the Blazers. 19 of them say yes. Can you estimate the true or the population proportion of people who like the Blazers? With, let's do 99% confidence. So step one, choose a confidence level, which we chose to be 99%. Step two, find the z-score. So let's hop over here. We're going to use a Q-norm. And we're going to go halfway between our confidence level and 1, which is 0.995, mean 0, standard deviation 1, and we get 2.58, about 0.58. Step 3, find the sample proportion. That's going to be 19/24, which equals 0.792. Step 4, find the standard deviation of the sample proportion. Okay, so the standard deviation of the sample proportion is very similar to the standard deviation of the sample mean. It's going to be the standard deviation of the sample divided by the square root of the sample size. Now, in the previous video, I explained that the standard deviation of a sample proportion is the square root of p times 1 minus p divided by n, where p is the sample proportion and n is the number of observations. So in this case, standard deviation of the sample is all right. So I'm sorry, I got a little brain fog. So the standard deviation of the sample proportion, we don't actually have to calculate with the standard deviation of the sample. We calculate directly as square root of p times 1 minus p divided by n. So the standard deviation of our sample here is going to be the square root of p, which is 0.792, times 1 minus 0.792 divided by, we asked 24 people, divided by 24. Let's find out what that is. 0.083 about. So that's the standard deviation of the sample proportion. And then step 5 is construct the confidence interval using p plus or minus and I'm sorry, I should be calling all of these p hats because they're sample proportions, so let me fix that. There we go. So it's going to be p hat plus or minus the z-score times the standard deviation of the sample proportion, which in our case is 0.792 plus or minus 2.58 times 0.083, which is 0.792 plus or minus 0.214. Which I can write as a confidence interval between 0.578 and 1.006. But there is something to keep in mind. You need to keep in mind that since a proportion can't be greater than 1, we truncate our interval to 0.578 up to 1.0. We just cut it off there because we can't ever be above 1.006. That's how you construct a confidence interval for a proportion. All right. That concludes the video for chapter 6. It's just a single video this week. We've talked about what a confidence interval is. At its core, it's a best guess in a reasonable range. We can come up with a mathematical best guess in a mathematical reasonable range. We start by choosing a confidence level, which gives us a z-score. We compute a sample mean and a sample standard deviation. R can help you find the z-score once you choose your confidence level. And then you need to find your reasonable range. I'm sorry, you need to find the sample mean, which in our example was 67, plus or minus the z-score times the standard deviation of the sample mean. And with a population proportion, it works very similarly. You're just building your confidence interval around a sample proportion, p hat, instead of a sample mean. All right, check in next week for our next chapter 7 videos.